Should any finance professional learn Python? And if so, who and why exactly? I know why I learned Python. I wanted to impress my boss by using machine learning algorithms, but not all finance professionals find themselves in the same position. So I realized that I needed to learn more about the value of Python for different kinds of finance professionals in order to communicate that to other people in our marketing. So I started a research project and I've learned a lot. And in this video, I'm going to tell you what I found. In order to succeed, a company must be able to identify with some degree of accuracy the tools that its employees need to solve the problems that they face. Companies mention these tools in their job postings because they want to hire candidates who can use them. So I decided to start my research by conducting a survey of job postings to understand how often and why successful companies hire finance professionals who can code in Python. My research assistant and I looked at over 2,700 job postings from 42 companies in different categories: banks, asset managers, private equity companies, and other companies like Amazon or Walmart or Toyota. Out of these 2,700 job postings, a significant minority, 10%, mentioned Python. 60% of the 42 companies had at least one finance-related job posting that mentioned Python. Investment management firms mention Python far more frequently than banks, private equity firms, or other companies, 39% compared to 13%, 6%, and 3%. When we slice this data by job type, we found that investment and portfolio management jobs mention Python most frequently, followed by risk management, research, and trading. Jobs in the categories of accounting, investment banking, and private equity didn't mention Python at all. Private equity companies did post some finance-related jobs that mentioned Python, but based on their function, I sorted them into other categories like investment management. Some companies mentioned Python in their job postings far more frequently than others. AQR Capital Management is on top, which is not a surprise since that's where Wes McKinney was when he invented Pandas, the popular Python package. BlackRock, Toyota, Fidelity, and JP Morgan also posted a high number of jobs targeting finance professionals who can code in Python. After we collected this high-level job count data, we selected 100 jobs to analyze in greater detail. We found that in 51% of these 100 jobs, Python satisfied a requirement, and in the other 49%, Python satisfied a preference. Most of these jobs indicated that Python would be used for data analysis. They also mentioned things like modeling, automation, and working with large data sets, but most, if not all, of these other uses could be grouped under the umbrella of data analysis. So we know what Python is being used for. Out of these 100 jobs, 20 mentioned Python exclusively, but 80 mentioned Python alongside alternative tools by saying things like the successful candidate must have experience in a high-level programming language like Python or R. Some of these alternative tools were mentioned more frequently than others. We mostly saw other high-level programming languages, SQL, VBA, R, and MATLAB, as well as the data visualization software, Tableau. And different types of job postings mentioned alternative tools with different frequency. After completing my analysis of the job posting data, I became interested in precisely understanding the similarities and differences between Python and the most frequently mentioned alternative tools. As I compared tools, I found that differences mostly fell into the categories of scope of utility and interface abstraction, and I'll explain what I mean. Some tools are designed for a relatively narrow purpose, whereas others are designed to be more generally useful. Tableau, for example, is a specialized data visualization tool, whereas Excel is good for data visualization, as well as statistical analysis, financial modeling, and more. So in this case, Excel would have the wider scope of utility. Further, some tools make their functions available to users through relatively simple, high-level interfaces, and other tools make their functions available through more complex, lower-level interfaces. The former category, tools that have abstracted further away from the underlying computing machine, are more convenient, but tools in the latter category are more powerful, meaning they provide users with greater potential, even if actualizing that potential sometimes requires more work than actualizing the relatively limited potential of higher level tools. As I mapped Python and alternatives across these two dimensions, I found that they arranged themselves in a diagonal line. Why? Well, IKEA sells furniture kits. Home Depot sells raw materials and tools. Anything that you can buy from IKEA, you can build using products from Home Depot. But why would you do that? If all you need is a cheap dresser, you'd be wasting your time going to Home Depot and building it yourself. But If you want to build a custom deck in your backyard, you need to go to Home Depot. IKEA doesn't have what you need. Home Depot doesn't beat IKEA on convenience. It beats IKEA by providing customers with greater potential. Businesses like IKEA and Home Depot compete with one another by occupying a unique position across the efficient frontier of the trade-off between convenience and potential. One business can take sales from another by providing greater convenience with the same potential or greater potential with the same convenience. And for this reason, the efficient frontier of this trade-off expands outward over time. Like a business, in order to compete with other software, computing tools must occupy a unique position along this efficient frontier. And for that reason, when we look at Python and its most frequently mentioned alternatives, we find them arranged in this diagonal line. If a tool provided no more utility, but it was more complex than an alternative tool, it wouldn't be competitive. The only reason why we use more complex, lower-level tools is because they provide us with greater potential. After mapping these tools, I sorted them into 4 categories. And in this video, we're going to walk through each one of those, and I'll give you a few comments on each tool. First, we're going to look at the tools in the upper left-hand quadrant that I'm calling graphical analytical software. Since its inception, Tableau has helped relatively non-technical users to analyze data by providing them with a high-level, drag-and-drop graphical interface. Creating interactive dashboards is simple and intuitive with Tableau, but the software is costly and its features are limited compared to some of the other tools that we're going to look at later. Power BI is not significantly different from Tableau across the dimensions of scope of utility and interface abstraction, but it is about 10 times less expensive than Tableau. Alteryx is another drag-and-drop analytical tool that's more expensive than both Power BI and Tableau. It's about $5,000 per year. Although these 3 tools provide similar capabilities through similar interfaces, users prefer Alteryx for data preparation and predictive analytics, and Tableau for data visualization. Users interface with Excel and SAS largely through high-level programming languages, Excel's formula language and the SAS language. So I classify these tools as hybrid software. Like Tableau, Power BI, and Alteryx, Excel and SAS support accessing, transforming, and analyzing data and communicating insights, even through interactive dashboards. Further, the additional flexibility provided through the lower-level interfaces of Excel and SAS allow users to perform tasks that aren't possible in the higher-level software, like financial modeling. Excel is available for free with limited features or as part of Microsoft 365. You probably have it on your computer already. SAS doesn't publicly share their pricing, but users say that it's similar to Alteryx, several $1,000s per year. In the bottom left quadrant, we have special purpose high-level programming languages, SQL and VBA. SQL is for interfacing with relational databases, and VBA is for extending and automating Microsoft Office applications. Both languages are simple and more or less intuitive. For example, this SQL code would retrieve the date and amount columns from a table named transactions for all transactions with an amount greater than $100, which is what you would expect from reading it. This VBA code would add the text new text to cell A1 of sheet 1 in an Excel workbook. Any action that a user can perform in Excel can be represented in and therefore automated with VBA, but the same is true for Python. A VBA user would extend his capabilities far beyond automating Excel by learning Python, but a Python user would gain very little by learning VBA. On the other hand, if a Python user wants to interface with a relational database, he's going to need to learn something about SQL. Python does offer packages like SQL Alchemy for interfacing with relational databases, but relational databases are so closely related to SQL that learning a package like SQL Alchemy is almost the same as learning SQL. It's like a Pythonic dialect of the same language. While SQL is a necessary complement to Python in certain circumstances, it's not a general purpose tool. For this reason, most relational database management systems allow users to embed Python code in SQL. Now we're going to skip ahead to the bottom end of the spectrum and look at the one relatively low-level programming language on the map, C++. The 100 job postings that we analyzed in greater detail only mentioned C++ twice, but I included it in this map because I want to show you that it's necessary sometimes for finance professionals to use even lower level tools than Python. The increased control provided by C++ allows users to develop even faster programs for demanding applications like high-frequency trading. C++ is more complex and less intuitive than the other programming languages on this map. For example, In order to calculate 2 plus 2, store the result in a variable, and then display the value of the variable, you'd need to write this code here. Keep this in mind because we're going to see some equivalent examples in just a second. Finally, in the middle of the bottom right quadrant, we have general purpose high-level programming languages, which includes Python and its closest alternatives, R and MATLAB. Each of these languages has a similar syntax. For example, the code that you see here is functionally identical to the C++ example that we saw a second ago. It adds 2 plus 2, stores the result in a variable, and then displays that result. Despite their similarities, Python, R, and MATLAB differ widely in their popularity. In the third quarter of 2024, there are over 2 million GitHub developers using Python compared to 100,000 using R and 50,000 using MATLAB. The most obvious reason for this difference that I've been able to find is that Python provides more tools than either of the other languages. 600,000 packages compared to 50,000 from MATLAB and about 22,000 from R. Of course, one reason for this difference in package count is the difference in the size of the communities that develop them. These two factors reinforce one another. A more popular programming language is going to have a larger and more productive community that makes more tools, and the abundance of tools will make that language more popular. One important subset of community-generated tools is APIs, which allow users to interface programmatically with other software. In the domain of APIs, Python is a first-class citizen. R and MATLAB are not. Bloomberg, FactSet, OpenAI, and Grok, for example, provide official Python APIs, but they don't provide official APIs for R or MATLAB. It's important to note that package count is not a perfect proxy for the convenience or the scope of utility of a language. These three languages have more functionality in common than you might guess from the chart that we just saw. The reason for this is that a small number of those 600,000 Python packages provide most of the functionality that Python users need most of the time, and R and MATLAB usually offer an equivalent for those fundamental packages. In conclusion, companies of all kinds, asset managers most of all, hire finance professionals who can code in Python. The primary reason for this is that Python is uniquely useful for enhancing and automating data analysis. Other tools like Alteryx and VBA offer some of the same functions as Python, but Python provides the most tools in one platform at no cost. My personal experience leads me to believe that job postings are a lagging indicator of the utility of Python in finance. Just because a job category doesn't frequently mention Python doesn't mean that a professional working in that category wouldn't benefit from learning Python. When I went through recruiting to become an investment banking analyst, nobody asked me if I knew how to code in Python, but after I got the job, I was able to use Python to apply machine learning to deliver better advice to my team's clients, and that was good for my career. The people who hired me weren't aware of this opportunity, and so they weren't looking for somebody who could code in Python, but the opportunity was there. Python is 3 times more popular than C++, 20 times more popular than R, and 40 times more popular than MATLAB. If the historical trend continues, Python will continue to grow in popularity, and along with its popularity, the developer community and the tools that they produce will also grow. This productive community assures Python users that they'll retain access to cutting-edge tools like the OpenAI and Grok APIs as technology and business needs evolve. So, now that I've completed this research project, I think I have a pretty good understanding of PyFi's marketing message. If you're a finance professional who's completely satisfied with the high-level tools at your disposal, or if you're not very technical or you're not very creative, then learning Python is probably not the best use of your time or your money. But if you are creative and you are technical and you're held back by IKEA-grade equipment, then expand your toolbox and build new solutions using Python.